Okay, so here's your one sample problem for section 1.3. If you notice, this problem right here was the exact problem I used for the pre-lesson video. I'm just going to use this as the final sample problem, and we should be ready for our homework after I finish this guy. So, just to kind of solidify our thinking, this is called piecewise defined function, okay? That just means there's three. To begin, this is basically y. So we got y equals 3. That's the first thing we're going to concentrate on. Now, if I say something about the graph and you're like, whoa, that threw me, just type this in Desmos just to verify this stuff. But that is a horizontal line, and it crosses the y-axis right at 3. And there it is. Now, the problem with leaving it like that is this limitations on the domain here. X is greater than -4, so that means when I get to -4, 1, 2, 3, 4, I can forget about the rest of the graph, and that's an open circle because it's strictly greater than. Remember, read from the letter to the number. Don't read this left to right. A lot of students go -4 is less than X. Don't do that. Your brain's going to play tricks on you. It's X is greater than -4. So I got to think about everything to the right of -4. But X is less than or equal to -1. So -1 is right here, and I'm filling that in because it's or equals. And I can erase everything else. I made a mess. All right. Welcome to math. All right. So I can fill that in because that is this graph contained by that domain. Now I'm going to move on to the next portion. The next portion is y equals -x. Now here's how your brain needs to operate. You have to think, okay, wait a minute, what's the parent function here? Well, that's just y equals x. That means if I made one of these little doohickeys, if this is -3, this is -3. If this is -2, this is -2. If this is 4, this is 4. If I plot all those points, and again, you can go to Desmos if you're confused, that's going to look like this. I'll write it over here so I don't make my drawing so messy. It's going to look like this. Well, what does this negative do? Well, remember what we learned about in translations and transformations. That's going to flip this guy over the x-axis because that's a negative in the front. That's the letter A. So if I flip this, everything above the x-axis will then go below. Everything below it will then go above. It's going to end up looking like this. And I'm going to kind of sort of draw that in, but I'm going to use very light dotted lines. Hopefully you can see that somewhat. And there it is. But the limitations are my domain x is greater than or equal to 0. So that means I want from here, remember I filled that in because it's greater than or equal to, but less than or equal to where x is 2. So I go out the x-axis 2, it matches up with that point. So all this wants is that piece. Hence the name, piecewise. Okay, I'm going to get rid of all these little smudgies. And on to the third part. Y equals 3 minus x. Now, just like on the pre-lesson, I rearrange these. You don't have to, but that's my preference. Y equals -x plus 3. All right, so I know, because we've graphed a million of these, that this is my y-intercept, 1, 2, 3. I know it goes through there. And then this is my slope, down 1, right 1. And so down 1, right 1, looks like that. And if I was to draw this in with a nice dotted line, it would look like that, with a little bit of ish. Here's the limitations. X is greater than 2. So I go out to where x is 2, and that would be right here. And whoopsie, those are the little mistakes we can make. That needs to be an open circle because x is strictly greater than 2, not including it. But x is also less than 4. So if I go out 1, 2, 3, 4, find out where that corresponds. It's right here, open circle. So this graph with this domain is smudged right in there. That's the piece we're interested in. The rest of it, we're not going to let that bother us. So there, we've taken care of their first direction. Graph it. All right, we're done. Now they're going to get tricky with us. What's the domain? Well, if we look at, so I'm going to write this over here, domain of this function. If we look at this piece right here, we can see that x is greater than, how far to the left does it go? 1, 2, 3, 4. But that's negative. How far right does it go? It goes to -1, and it's a filled in dot, so I got to make it less than or equal to. Another way to do this is to go -4, -1, brackets. But this is what they want for today. For some reason, they just want us to practice that now. Now, we can see that this, if we're thinking domain, overlaps this. They actually share this point right here. That right there, this graph goes from here to here, talking left to right, and then it picks up here, and it continues left to right. So we're going to capture this by saying, and it moves from here, filled in 0, so x is greater than or equal to 0, and it continues all the way. You might say, well, that's open circle, but this is closed, so it includes this part of its domain, and then it just keeps going all the way to 4, but that's an open circle, so that's strictly less than. So these two things circled are domains. That's how the book's going to do it. And now we're going to talk about the range. The range is going to look a little different than what you guys are used to. It starts out pretty easy because from here to here we've got this overlaps this. So this graph goes from -2 all the way up to 1, but this is my range, so it's y. So it's greater than or equal to -2. Why greater than or equal to? Because that's filled in. Then it goes up to 1, but that's an open circle, so I have to just go less than 1. And, now here comes something weird. This line right here is where y equals 3. That's exactly what this said originally. So it has to include just that value, 3. They might write it a little different, but the bottom line is that needs to be included in our range because it's included in our graph. And there's the range. Now, what about increasing or decreasing? The important thing that I emphasized was, when I taught this, you got to think roller coaster, and you must move left to right to determine whether or not you're increasing or decreasing. So let's act like we're on the far left of this roller coaster, and we go this way. Are you increasing or decreasing? Neither. It's flat. So now let's go to this roller coaster. If we were on this here, we're going to be decreasing. And if we're on this one, we're going to be decreasing. So it says, over what intervals is it decreasing? So for this one, I know it's decreasing. Hopefully I'm not running out of space. And the interval there is decreasing from 0 to 2. And that one is also decreasing, but that's an open circle from 2 all the way down to -2, but that's parentheses because neither of them are included because of the open circles. So those are the intervals. And that finishes that question, and that finishes this little sample problem. I think you guys are really, really, really ready to go for your homework. All right, good luck.